So here we'll talk about matrix operations. And before we do that, we should talk about some notation. So a matrix is just a rectangular array of numbers. And these are typically denoted by capital letters, A, B, C, etc. When we do the size, we do the rows by the columns. So, for example, this matrix right here has 3 columns and 2 rows. So this would be a 2 by 3 matrix. Any matrix with only one column is going to be called a vector, and these are typically denoted by bold lowercase letters, such as this boldface A. So usually this will be indicated when we're handwritten with an arrow on top, since it's a little bit harder to write a boldface letter. So a lot of times we talk about a matrix in terms of its column vectors. And in that case, we can denote a matrix as A is equal to A1, A2, etc. up through AN, where each of these is just a single column of A. And finally, the entry in row I in column J is denoted by A sub ij. So what about adding matrices? Well, if the matrices are the same size, we add them by adding their corresponding entries. If they're of different sizes, they cannot be added, and then subtraction will follow these same rules. So if I want to add up these two matrices, I just add up things that are in the same spot. -4 minus 6 is -10. 1 plus 0 is 1. 8 plus -2 is 6. Move down to the second row. -1 plus -3 is -4. -4 plus -5 is -9. And then -5 plus 5 is 0. As I said, subtraction follows the same rules. We just need to subtract corresponding things. -7 minus -5 is going to be -2. -4 minus 0 is -4. -9 minus -5 is -4. 5 minus -4 is 9. -1 minus -1 is 0. And 7 minus 3 is 4. I also pointed out that matrices have to be of the same size. So this one right here, the first one is 2 by 3. This second one is a 3 by 2. So this is undefined. We cannot add these two matrices. The next operation would be multiplying a number and a matrix. So a scalar is just going to be another name for a number. And if we have a scalar in a matrix, Ra is known as a scalar multiple of the matrix A. And we find this by multiplying every entry of the matrix A by the number R. So this example here, just multiply everything by 3. 3 times 3 is 9. 3 times -8 is -24. 3 times 8 is 24. 3 times 5 is 15. 3 times 8 is 24. 3 times -2 is -6. 3 times 3 is 9. 3 times 4 is 12. And 3 times -9 is -27. So a few properties of addition and scalar multiplication. The first one, A plus B is equal to B plus A. So this is commutative. In addition, A plus B plus C is equal to A plus B plus C. So we also have the associative law. A plus 0 is equal to A. So this 0 here is just a matrix with all 0 entries. We also have our distribution laws. R times A plus B is the same thing as RA plus RB. And then R plus S times A is the same thing as RA plus SA. And finally, R times SA is the same thing as RS times A. So we can move these parentheses around a lot.